Hi, this is Algebra 1, Module 4, Lesson 4, greater than. So now we're going to start looking at inequalities and seeing if we can find some rules or some different things, some patterns as we're looking through them. So for each situation, you're given a mathematical statement and two expressions beneath it. So first, we're going to decide if the two expressions, which of the two expressions is greater, if the expressions are equal, or if the relationship cannot be determined from the statement. Then we're going to write an equation or inequality that shows our answer and explain why your answer is correct. So we just got to be careful because this can be tricky. So the example is x equals 8. Which is greater, x plus 5 or 3x plus 2? Well, the 3x plus 2, because if you substitute 8 in there, you're going to get numbers that you can work with. So let's try it over here. The statement, y is less than x. So they're saying which is greater, x minus y or y minus x? So let's just pick some numbers to work with first. So I'm going to go ahead and just put in, if we have y equals 3 and x equals 5, then the x minus y is 5 minus 3, which is 2. And then it says, or we have y minus x, which is 3 minus 5, which equals negative 2. So in this case, x minus y, 2, is greater than y minus x. In this case, the x minus y is greater than y minus x. Is that true all the time? Well, let's try y equals, let's do y being a negative 10, and x is a negative 2. Let's try some negatives because sometimes that throws it off. Then if we do x minus y, negative 2 minus negative 10, that equals positive 8. Or our next one is, going to flip them, so negative 10 minus negative 2 would equal a negative 8. So in this case, still our x minus y is greater than y minus x. So notice in both cases we use the smaller number as the y. So, so this is true if y is smaller than x. So we found out at least what makes it true in there. All right, next one. Oh, that one green. We'll do the next one in purple. All right, so this next one, which is greater, 5 or x? So 2x minus 3 is greater than 7. So 5 or x. So what do we need to do? So let's substitute in there. 2 times 5 minus 3, that equals 10 minus 3, it equals 7. So 5 works in there to make it equal. So to make this true, this 2x minus 3 true, x has to be greater than 5 to get a number to make, let's see, to make 2x minus 3 greater than 7. So if we put in the 5, it can't be equal to 5. Because if we put in 5, they're equal, and that's not an equal, it's a less than, so, or greater than. So it can't be equal. So we can do it, but x has to be greater than 5. So statement 10x minus 2, 10 minus 2x is less than 6, which is greater, x or 2. All right, let's try this one. Let's start by substituting in um, our 2. So 10 minus 2 times 2 equals 6. Okay, so if we substitute in a 2, it makes them equal. So x would have to be, so x has to be less than 2 for this statement. True. Okay, next. 4x has to be less than or equal to 0, which is greater, 1 or x. Well, if we do like we've been doing, 4 times 1 equals 4, which means that doesn't make this true. So um, the only thing for x can be to make it equal is 0. And otherwise, it's got to be negative, right? So x needs to be less than or equal to 1, not 1, 0, 0 to make this true. 0 to make this true. Because even 4 times 1 doesn't work. 4 times a half still doesn't even work because that's still a positive number. So it really has to be 0 or a negative to make that one true. All right, next one. 5. N is an integer. Which is greater, n or negative n? All right, well, if, let's go ahead and put this one in green. Well, let's just say if n is positive, then, so let's just say positive 4, 4 or negative 4. Which one's going to be bigger? Okay, well, if n is positive, then n is greater than negative n, right? 4 would be greater than negative 4. But if if n is negative, which would be bigger? Well, negative 4 or the opposite of negative 4, which is a positive 4. It'd actually be the other way around. So if n is negative, negative n is greater than n. Well, we've done positives, we've done negatives. What about 0? Um, if n is 0, then, well, 0, is that greater than or equal to negative 0? Actually, it's equal to. Then n is equal to negative n. But this kind of depends on what we substitute in there. It's not just automatically bigger or smaller, just depends what you're thinking of. A lot of people forget that the negative is not an automatic positive in there. All right, 6. Which statement is greater? Or statement x is greater than y. So x plus a or x plus y, which is bigger? Well, if we put in any number in there, let's just try it. Let's just say x equals 2. Let's do 3. We don't like to use 2. And a equals 5. Okay, let's see what we get here. Then 3 plus, oh, y, we need a y. X equals 3. Y equals 4. And a equals 5. Okay, then 3 plus 5 equals 8. Now, is that greater? Let's just put the symbol to see if it's true. 4 plus 5. Oh, wait, I did that backwards. X has to be greater. So Y has to be 2. There we go. And pay attention to the first one. Okay, so if X is bigger, then if I add 5 to each side, 8 is still bigger than 7, right? Okay, so that's true. Let's try one more with negatives just to make sure. So let's do x equals, and x has to be bigger. So let's do -4, y equals -6, and a still equals 5. Okay? Then if we have -4 plus 5, that equals 1. Is that still greater than what we have here, -6 plus 5? Yeah, that's -1. So it looks like even if we have positives or negatives, they still, x will still stay bigger than y, which makes sense. If you're adding the same thing to both sides, you haven't really changed what's going on there. Okay, what about the subtraction piece? Well, that's kind of similar to what we did in our practice problems the other day. We tried adding and subtracting to an inequality. So let's see. Um, if we do kind of the same thing, let's just use our same ones from before. X equals 3, y equals 2, a equals, let's just do 5. Then we have 3 minus 5, which equals -2. Is that greater than 2 minus 5, which is -3? Yes, that works. Let's try it one more time. Let's do it with negatives. X equals that -4, y equals -6, and a equals 5. Then let's do, what do they say, minus -4 minus 5, which is -9. Is that still greater than 2 minus, sorry, -6 minus 5, which is -11? Yeah, that still works. Just like in our practice problems the other day when we had to do those, adding and subtracting didn't change that outcome of our inequality. 8 though, 5 is greater than 4. So if I substitute a number in for x and multiply it by each of these, then do I get, does this keep this true? Okay, well, that multiplication piece kind of throws things off sometimes. Let's just say if we do a positive, if x is positive, what happens? So 5 times 3, 15. 4 times 3, 12. That's still going to be bigger, right? Then 5x is still greater than 4x, right? Have a positive number, they're still going to work. What if x is negative? Well, if I do a -3 this time, that's -15, -12. Well, now the 4 is bigger. So 4x is actually bigger than 5x. Well, what's our other option when it comes to positive, when multiplication? Zeros. I'm going to scoot these over here so we have a little more space. If x equals 0, then I have 4 times 0 is the same thing as 5 times 0. Both of them equal x. So it just depends on what we use to be able to do these. I'm going to shrink this just a tad so it fits in there a little better. Okay. Nope, still going to cover over. All right. Next one, number 9. Which is greater? Now we're going to try the division piece on here. So let's try this idea again. I'm going to start these guys over here. So if this number is positive, x is positive. Oh, not going to have room. All right. We'll try it right underneath. We'll move this guy up a little bit. Okay. So if x is positive, so let's just use a 2 in here. I know I don't usually like to use 2s because that can throw off stuff, but it's easy to divide by 2s. So 5, half of 5 is 2.5. Half of 4 is 2. Okay, divide them by a positive number. Then our 5 over x is still greater than 4 divided by x. What if x is negative? Well, then we end up with those negative numbers again. So 5 divided by a negative 2, that's negative 2.5, which is actually smaller than negative 2. So again, that kind of flips this around, doesn't it? My 4x is actually bigger than my 5 over x. And then we always have if x equals 0, 0, can we divide by a 0? We can't. Then both of them are undefined. What we say when they equal 0, when they divide by 0, you just can't do it. So it's undefined, it's not possible. All right, last two. The statement x is less than or is greater than 0 but less than 10, and y is greater than 0 but less than 12. Which is greater, x or y? Well, there's a lot of numbers they both can be. So I'm going to say on this one, we really can't determine it. We can't determine the answer from the information given, right? Because um, we really need to have a little more information because, I mean, they could be equal. X could be 1, Y could be 2, or Y could be 1 and X could be 2. We don't really know since so many of those numbers overlap. Um, Last one, 11. Which is greater, in or 1? Well, if I substitute that 1 in, so 3 to the, say, 1 plus 2 power. Well, that's 3 to the third, which actually equals 27. So n has to be, for this to be greater than or equal to, has to be greater than or equal to 1 for this to be true. So if there's a 1 in there, they're equal. If we want this side to be bigger overall, it's got to be bigger, 1 or bigger. Right, that is it for these notes. Thanks for joining us. See you next time.